Good day, ladies and gentlemen. We are continuing our series on differential equations by looking at the 2015 AP test, question number 4. We have a differential equation given by that where the slope is 2x minus y. All right, question A. We're going to draw a little slope field, only 6 points, so not so bad. We're going to have 6 points, and we're going to find their slopes, and then the slope field is we just graph a little teeny slope of what it should be at that point. All right, so let's start right up here at 0, 2. What else? We got 0, 1. We have 0, negative 1. Then we have 1, 2, 1, 1, and 1, negative 1. So we'll put those points into this equation and see what we end up with. So 2 times 0 minus 2. 2 times 0 minus 1. 2 times 0 minus negative 1. 2 times 1 minus 2, so that's 0. 2 times 1 is 2. 2 minus 1 is 1. And 2 times 1 is 2 minus negative 1, so we should have 3. So at 0, 2, we draw approximately a slope of a negative 2, a negative 1, and a 2. At 1, 2, we have a slope of 0, a slope of 1, and a slope of, whoops, that's a little steep, but the idea is slope of 3. So something like that. Again, slope fields don't have to be perfect. They just have to show you know what you're doing. So generally the shapes are good, and there's your data to back it up. All right, find the second derivative in terms of x and y and determine the concavity for quadrant 2. So let's take a look at that. Let's take the second derivative, see what we get. So with respect to x, so the derivative of 2x with respect to x is 2, and the derivative of y is y prime or dy dx. So our second derivative is given by this. Now we know what dy dx is. It's 2x minus y. So our second derivative is really 2 minus 2x plus y. Now they ask us specifically about quadrant 2. So remember, quadrant 2 over here, what do we know about the values of all the quadrant 2's? Well, x's are negative and y's are positive. So let's use that information and see what happens. So if I put this into here, d squared y over dx squared, which is second derivative, 2 is going to be 2. If I put a negative value for x, if I subtract a negative, I'm going to get a positive. So I'm going to get a positive number plus another positive number. So again, I don't know what those exact numbers are, but what I know is that dy dx will always be greater than 0. It would have to be. You have a positive number, and a positive number. So because the second derivative is always positive, all of the concavity is concave up. So the solutions are concave up. And the reason for your answer is that right there. So it's a weird question, but again, if you know how do you deal with concavity? Concavity is the second derivative. You know if it's positive, it's concave up. You know if it's negative, it's concave down. So take the second derivative and find out. It was greater than 0, so it's concave up. Similar for this question. It's asking you if it has a max or min or neither at 2. Well, for f of x, how do you find a max or a min? You take its derivative. If the derivative is positive, it's increasing. If the derivative is negative, it's decreasing. If the derivative is 0, it's potentially a max or a min. It's a critical number. Well, for the function f of x, we already have the derivative. We don't have to find it. It's already given to us. We have to find it when x equals 2. Now, it's very nice that they happen to tell us this. When x equals 2, y equals 3. So we are going to plug in both those values. We're going to plug in 2 for x, 3 for y. We end up with 1. Well, if it's 1, then it's not a critical number. At that point 2, 3, this function is increasing. So, easy to say is f has neither a relative max or a relative min at x equals 0. I'm sorry, x equals 2. And your reason is right there. So not a difficult question. It's a very oddly asked question. And speaking of oddly asked questions, here it is. Here's the question that drove me crazy. So let's go through it and see what you can think of it. Find all values of the constants m and b for which y equals mx plus b is a solution to the differential equation. Okay. Started out okay. I know that my equation that I want to find is y equals mx plus b. Now typically what I'd want to do is solve this differential equation and do all kinds of things. I can't really solve it. And I don't have to solve it. Because here's what I know. If I want to know if this is a solution to that equation, if I take the derivative of this equation, I end up with m. Which kind of makes sense. If you have mx plus b, the slope is m. So I have this dx over dy equals m. Well, dx over dy equals 2x minus y. So I want to check this out and find out when m and b make that true. Now here's the problem. There's no b in that equation, is there? But I do know another piece of data. I know y equals mx plus b. There's a lot of substitution in this problem. So 2x minus. Now in place of y, I'm going to put mx plus b. That's going to equal m. Alright, now I'm just going to multiply this out. And I'm going to bring the m over. Now here's the tough part, because we don't do equations like this very much. The question is, how do I find m and b that make this true? Think about this. If I want this equation to be 0, both this term and this term have to equal 0. Let's make both of these try to equal 0. So, if I let that be true, and I let this be true, let's see what I can come up and figure out. Because if these were both equal to 0, this would be a true equation. So if I can solve this one. M would equal 2. So if m equals 2, let me plug that in there. And b would equal negative 2. And if you put those values in to this equation, they end up being true. So those are your two answers. M is 2 and b is negative 2. Like I said, this question drove me crazy. And I finally figured it out. It wasn't easy. And I'm pretty much sure that if I had this in the actual APS and I was doing it, I would get it wrong. So, that being said, I'll leave you with that one. And we'll continue our series a little bit later on. So have a good night. Bye.